In this video, I will be talking about Le Chatelier's principle. Le Chatelier's principle says that if you induce a stress on a system at equilibrium, the equilibrium will shift so as to relieve that stress. But wait, actually not this stress or the feeling of emotional and physical tension. I mean stress or changes that we could use on a reversible chemical reaction to unbalance its equilibrium. Let's say this is our system. Then the factors that control the direction of a chemical equation are heat energy by increasing the temperature of the system, increasing or decreasing the pressure of the system, or increase the concentration of the reactants or products. Once you understand these factors, you become able to control the direction of a chemical equilibrium. If you were a chemical engineer and you are in charge of production of ammonia using this chemical equation, you need to choose conditions that favor the desired product as much as possible. That is, you want the equilibrium to lie far to the right. Fritz Haber was developing the process of the synthesis of ammonia. After extensive studies on how temperature and pressure affect the equilibrium concentration of ammonia, he noticed that the production of ammonia is favored by conditions of low temperature and high pressure. Let's see some examples of a stress we could put on a system at equilibrium. We could modify the concentration of any of the compounds. Look at this chemical equation. Let's say we add some of a reactant. That will unbalance the equilibrium, then but the forward reaction will speed up to use some of the additional reactants and turn them into products and restore equilibrium. The equilibrium is said to have shifted right. If we add more products, it would shift left. Likewise, if we selectively remove one of the components, the equilibrium will shift to produce more of that species to restore balance. That is one type of stress we could put on a system. Another stress would be to change the temperature. To see how this would affect equilibrium, we have to see whether a given reaction is exothermic or endothermic. This tells us whether a reaction absorbs or releases energy and is signified by delta H, or the change in enthalpy. If delta H is negative, the reaction is exothermic and releases energy, so we could think of heat energy as a product of this reaction. If we increase the temperature of the system, means more heat, so equilibrium will shift to the left to use up some excess heat. If instead it's positive, that means it's endothermic and energy must be absorbed for the reaction to go. So we could think of heat energy as a reactant. So if we increase the temperature of the system, means more heat, so equilibrium will shift to the right to use some of excess heat. Higher temperature means more heat, so equilibrium will shift to the other side to use up some excess heat and relieve the stress. Cooling it down would have the opposite effect. The third stress we can examine is changing the volume or pressure. Let's say the equilibrium involves gases in a container. What if we decrease the volume of this container? If we remember Boyle's law, we know that the pressure will increase. Since the smaller the volume, the more particles will hit the sides and exert pressure. If there is a difference in the number of moles of particles on either side of the equilibrium, it will shift towards the side with the fewer particles, so as to remove some of the additional pressure. Between nitrogen gas and hydrogen gas to form ammonia, we can see on the left side we have twice as many particles as right side. If we decrease the volume, thereby increasing the pressure of the container, so equilibrium would shift towards the side with the lower particles to remove some additional pressure.
So in this example, check which side has lower particles. Obviously the product side, so equilibrium will shift to the right. Thanks for watching, and if you have any question, please don't hesitate to leave it in the comment.